Hello, thank you very much for having me. I'm Max Sklar. I am a data scientist and an engineer at Foursquare. I've been here for about 4.5 years. And the title of my talk is Places and Tastes, Where People Go and What They Do There. So as you can tell at the end, there's basically two parts to what I want to describe to you today, two different systems that we built that I think are pretty neat and maybe I'll have some questions about it, maybe I'll have some ideas for them. Okay, so first I just want to give you an overview of our two apps because, okay, good. I just want to give you an overview of our two apps because, not everyone's familiar with them, because it'll give you an idea of why we decided to build this stuff. So Swarm is our first app. It's for keeping up and meeting up with friends, that's what I'm describing. There's one basic thing you do with Swarm, and that is you check in, which is a big old check-in button. You press it, and then a bunch of venues come up. Hopefully the venue that comes up first is the one that you're currently at. And then, you write about what you're doing, and then you press check in, and then it shares it with your friends. And on the other side of that, you can see where your friends are, what they're doing, and it sort of helps keep in touch with your really good friends, and it helps meeting and that sort of thing. There's also a bunch of gamification type stuff, so you win stickers and coins, and it's sometimes like a casino where you win like 20 coins, and you hear the Super Mario sound. So Foursquare is the older one, or this is the one that people know a little bit better. Our tagline was, or it still is, Foursquare learns what we like to lead you to places that you love. So what that means is a local, personalized local recommender system. So what you do there is you search for places. You find restaurants, you can find parks, you can find buildings, things to do for fun, whether you're a tourist or a local, everything's got a rating. You can discover new places, so we try to figure out how we can give you good recommendations, even if you haven't searched for anything in particular, because most of the time we're indecisive, we don't know exactly what we want. And the main thing that you do there, the main content that you leave, is you leave tips for others. So you write 2 or 3 sentences about the place. Now this could be a review type thing, where you say whether it's good or bad, like but sometimes it's more of a helpful type thing, where you say, hey, you're at this restaurant, this is the first time, this is what you order, or you're at this park, this is the best place to go hang out, etc. And another piece of it is passive recommendations. So these are, you don't actually have to check in or trust that you're there. We know if you've stopped at a place, we know where you are, and we'll give you the tip right out of the box. And if we get this right, then it's really, really good. If we get it wrong, it could be annoying. So we have to, build some stuff to make sure that we get it right. I kind of like the one on the top right here. When someone, went to IKEA, and then before they went in, someone said, if you want the hot dog before you go in, you have to enter through the exit door and grab one. Otherwise, you're going to have to go through the whole maze of the store before you get your hot dog. And so the person who got this thought that was really helpful. Okay. So a lot of this is based on our venue search technology, and what we have to do here is we have to take the information that you get from your phone, which includes, latitude and longitude coordinates from your GPS, and then we have to match it with a venue in our database. And our high-level strategy here is to use the Swarm check-in, where people tell us where they are. There are billions of those. And we use that as training data to predict the venue from this information. So you have a paper on it from 2013. You can see some interesting pictures here in the paper if you want to check it out. Because these are, each point is a check-in to a different venue. The one on the left that looks kind of like a bug, that's actually JFK Airport in New York. And those are the roads in and out. There's a bridge and I think a smaller place, maybe a bar in the West Village of New York. So this is using a mixture of Gaussians to kind of model these things. We've done a lot of them. And basically what we have to do is we have to take a lot of different models and then aggregate them using some secret sauce, kind of a mixture of trees kind of algorithm to try to figure out to try to actually get our final model. So I can't talk about every component here, because that would just take too long, but I just want to talk about the main one, which is k-nearest neighbor. I try to mention the most obvious one is just take the latitude and longitude coordinate and then pick the venue that has the closest center point. That doesn't really work. I mean, it works better than random, but it doesn't work that well because it's, venues have, as you can see there, just very different shapes and sizes. And what do we use this for? Well, we use this for our passive location features in Foursquare, so we know where you are, we know what tips to send you. We use it for venue search and swarm, so when you're searching for something, when you want to check in, you know exactly where you are, you don't actually have to pick from a long list. But we've actually been trying to expand this technology out and get other people, other companies in the industry using it. So for example, you have Pinpoint, which helps personalize ad networks. So, hey, you know this person's been to the coffee shop several times, maybe a different ad network. All right, so I want to talk about the k-nearest neighbor algorithm for doing venue search. So the idea here is we look at the 30 closest check-ins. K is 30. It's not always 30. I just think of it as 30. It's kind of, it depends on the density. And then we say, well, where were those check-ins? The k-nearest neighbor is actually a perfect one for this. We have something called the recursive dimensionality of machine learning. But here we have the opposite, the blessing of low dimensionality, because we have two dimensions. And sometimes in k-nearest neighbor, you don't know how much to count each dimension. Should this one be worth 10 times as much as that one? Well, distance north and distance west should probably count the same amount, so you don't have to do that. And we get some really cool maps here of different venues. So this is Greenwich Village in New York. This is the NYU area. You can see Washington Square Park is in purple. If you look at the north side of the park, northeast side of the park, you see there's a little chunk taken out of it. That's actually because Washington Square Park has this giant arch in the front of it. And people over there are not checking into the park, they're checking into the arch. So we can kind of tell exactly where that is. You've got the library to the south in orange, green is the business school, and to the southeast of that. There. That's the computer science building. That's why there's a room like this. Here's another example. This is a mall in New Jersey next to a couple of highways with all these on-ramps and off-ramps that are impossible to figure out, as is common in New Jersey. And we have this, notice this purple kind of purple cloud around the mall. And it's not just the mall itself, it's also people coming and going from the mall. So you kind of see that the parking lot is, the parking lot is there, the road is there. Interestingly enough, not every spot in the mall is colored purple. You see a bunch of chunks taken out of it. As you can guess, those are actually individual stores in the mall. Whereas if you're there, we're going to know that you're in that store versus just in the mall in general. And there are a whole bunch of other signals that we use as well, aside from k-nearest neighbor. I don't get into all of them. A good one is which Wi-Fi signals that your phone can see. This is really helpful when you're in like a tall building. Say that you're on the 18th floor, you can see the Wi-Fi signal from the 19th floor, you can see the Wi-Fi signal from the 16th floor. You can't see the Wi-Fi signal from the first floor. So you have a good idea that you might be at the venue on that floor. We look at your user history. We've been looking at beacons, as you heard from Salvatore before. All right, and so now I want to get to, okay, good, I have some time. I want to get to the other system that I want to talk about, which is using your check-ins to track tastes. So we have whenever you check in on Foursquare, you can optionally add some text. And we have billions of those, and we have a data pipeline that analyzes these billions of shouts, as we call them shouts, in about a dozen or so different languages. And we do language identification, we break it up into words, we combine them into phrases, we do some grammatical analysis, we look for the noun phrases, and then we try to match those noun phrases to our database of tastes. Now, a taste could be, what you think of, it could be a food item, like, pizza is a taste, taco is a taste, but it could be anything that you might want to search for, really. So, outdoor seating is a taste, good for groups is a taste, Wi-Fi is a taste, etc. And this is a really interesting data set, which is what I want to share today. We can use this to track metrics on popularity across geography and across time. So let's look at time of week to start out with. This is a comparison between milkshakes, burgers, and pancakes in the United States. You see it's tagged EN because it's English. And you can see every morning pancakes are more popular than burgers. Milkshakes kind of peak right after the burgers. And then on Saturday and Sunday, the pancakes are way more popular. So we'll look at another one. This is, now we can look at it by region. This time we're looking at the same phrase for different countries. So we're looking at dinner, and you can see here, this is now a log scale, kind of dividing between, switching off between log scale and non-log scale of percentage of check-ins, just to illustrate the point better. But if you're curious to get into more exactly what the scale is in these charts. So as you can see, dinner in the United States peaks at a certain time of day. Dinner in the UK peaks maybe 30 minutes after that. Italians, 2 hours later. So it's really interesting to see this data. It really helps us with our recommendations as well. I noticed this is dinner in English in Italy. You could also look for it in Italian as well. We're kind of looking at aggregating that, which I think is really interesting. But the Italian version tells a similar story. Now, seasonality, we also look throughout the year. So, global seasonality, this is, our data is very biased towards the northern hemisphere. There's more people there. We have, you can see skiing is more popular in the winter months, as you might expect. Cold brew, iced coffee, popular in the summer. And then pumpkin starts getting really, really popular in September, October, and then right after October 31st, popularity comes. So let's break this down by country. We're looking for people who are mentioning their outdoor seating. And this is Canada versus Australia. It gets pretty cold in Canada in this winter, so you don't really want outdoor seating. So you can see how it's really low in the beginning of the year and the end of the year, the winter months. Australia is the data is a little flatter, but you can see how it's kind of flipped, how in what we call the summer months, you're less likely to search for outdoor seating. You're less likely to mention outdoor seating. You can search data too. Another interesting thing is you can look at various holidays in different countries. So often we get a much starker example. So here I searched for fireworks in the United States is in brown, fireworks in France is in blue, fireworks in the UK is in green. And so you can tell which time of the year each country has their holiday where they set up all their fireworks. You can also say everyone kind of goes up a little bit at the end of the year, so you can read. So now we're going to zoom out even further from seasons to year by year. Because some things aren't seasonal, some things just happen, like movies. This is a comparison of James Bond and Hunger Games, because both movies came out in 2012, and both movies came out, again, different movies, same franchise, in 2015. And you can kind of get a sense of, the blue is when Hunger Games peaks, James Bond peaks is the green one. You can tell when the movies came out. You can tell kind of the relative, I don't know popularity, but in terms of buzz, how many mentions there were. You can see that. You could also see it in terms of new trends. So in 2013, a bakery down the shop from us, or just a bakery shop down the road from us, decided that they were going to invent a new pastry. They called it the Krona. It was half donut and half croissant, I think. It took off in 2013. So notice there's literally 0 mentions from January to May, and then all of a sudden, you know, you see the popularity of this thing spiking, and then, you know, the hype kind of comes down a little bit, and then it sort of remains plateau. Here's another interesting example of flat white. So this is, I found this article in The Guardian explaining, so the background story here is that flat white is not popular in the United States. Americans don't know what it is. And then January of this year, Starbucks rolled it out on all their menus in the US. So this article tries to tell Americans what a flat white is. I read it, I'm not sure I get it still, but maybe I'll try it when I get home. But you can see that this story actually really kind of gets shown in our data. You can see how flat white in the UK versus in the US, it's, you know, the popularity difference is really stark. And then, you know, you can reduce it in the first month of January, actually I think it was January 1st. So, you know, all of a sudden it peaks, and then there's buzz, it gets even higher, and then it comes down after the buzz, but it's still higher than it was before Starbucks introduced it. So there are a bunch of applications of this stuff. The most important for us is awareness of global and local preferences for our recommender systems. We want to make sure that we give you the right recommendations at the right time, depending on wherever you are. We use it for, you know, trends for marketing materials. Actually, you can see this is from this picture up here is from our fall time tastes infographic that I put out, and we just put the graph right in there, so it's great. And yeah, there's a bunch of other interesting stuff that I'm looking into doing with it. You know, I try to supervise learning on it, trying to group tastes by how similar they are in terms of timeliness. So, you know, you kind of see something like happy hour, which has these a very distinctive pattern because it goes up at 5 o'clock every day on the weekdays, and there aren't really a whole lot of words that are similar to that. And then you see kind of, you know, a whole lot of terms that are similar to lunch, and, you know, differs by country. So anyway, all these graphs that you've seen, what we have an admin page where we can produce them on the fly. So if you've got any ideas at lunchtime, just let me know, and I'll produce some graphs for you. And if you've got any ideas about applications for this stuff, you know, I'd like to hear about it. It's a workshop. It's what we can do. Those are our systems. Thank you very much.